Now we're going to do some examples of factoring using our new techniques. So, some examples. Our first one, x cubed minus 1,000 equaling 0. So what we want to do is we want to factor this, that way we can find all the solutions or all the zeros. It means the same thing. So we notice that this is a perfect cube. Hopefully you notice that this one also is a perfect cube. We have right now the difference of cubes. Hopefully we remember when we have the difference of cubes like this, it factors down such that we have a minus b, then a squared plus ab plus b squared. So the difference of cubes looks like this. What we want to do is we want to first define what our a is here. So I want to look at my number, which is a 1. 1 times 1 times 1. It's going to go right there. Then x cubed. The cube root of that is going to give me just x. So this is my a, where if I take a and cube it, I get back here. What I want to do now is consider what b is. We ignore the sign, so we just want to look at the number. The number is 1,000. What number times itself 3 times gets you 1,000? Well, that's 10. So we just ignore the sign, and we find this number, the cube root of that. So we got b is 10. Now that I know a and b, I plug them in here, and it'll factor it for me. So a is now x, b is now 10. Then over here, a is again x. We're going to take that and square it, this entire term. Then we're going to take a, which is x, multiply it by b, which is 10. And then we're going to take 10 and square it. From here, I just want to simplify this down. I have x minus 10. Then over here, I have x squared plus 10x plus 100. So once we recognize the formula we need to use, difference of cubes, we then find a and b and plug in appropriately. Let's do another example. So what we want to do is we want to factor this. Currently, this does not equal 0. We don't want to factor until we have it equaling to 0. So what we want to do is move these two terms on the other side. So we have 8x cubed. Then we want to add the 2x squared to both sides. Next, we want to move the 8x by subtracting 8x to both sides. So I'm subtracting 8x to both sides. That leaves me with 0. So what I've done is taken this and written it so that it equals 0. Now that it does that, I want to factor. So what we have to do is we have to go through our techniques and see which category this fits under. Well, I notice first off that I have something in common with every term. So what I want to do first is take out something in common. So they each have an x. I'm going to pull out an x, and I'll be left with x squared plus 2x minus 8. Now that I've factored out the x, I want to see if this thing in here can factor. So what we want to do is now factor a quadratic, like we're used to. We want to think of our factors of 1, which are just 1 and 1. And think of our factors of 8, which are 1 and 8, 2 and 4. Going to leave this x out front just hanging around. Break this up into binomials to see if it'll factor. So my linear factors for x are going to be x and x. Then next, my factors for 8, the ones that are more likely to work are 2 and 4. So we're going to try those. This is negative, and that's positive. So one of my numbers has to be negative. The other one has to be positive. Let's try this. Just for a minute, I'm going to ignore this x out front. And I'm going to go ahead and FOIL these together to see if I get what's inside here. So x times x gives me x squared. This is going to give me minus 2x. That will give me plus 4x. And this gives me a negative 8. When I combine these two terms, I get a positive 2, which is what I want in the middle. That means that I factored this correctly. So all I've done now is taken this and factored it into linear terms. These are, again, my linear factors. When we're factoring, we're trying to get as close to linear factors as possible. All right, let's do another example. For this one, what we want to do is, again, we want to set it equal to 0. So I have to move the 64. I'm going to subtract 64 to both sides. And now it equals 0. What I want to do here, this is just something that you're going to have to recognize. It takes a little while, but because this is x to the 4th and x squared, you can think of this as a quadratic. What I want you to consider is let's let a equal x squared. So every time we see an x squared, we're going to replace it with a. So right here I have x to the 4th. If I take a and square both sides, if I square this side and square that side, I should be able to do that, because if I do the same thing to both sides of an equal sign, it should equal. This gives me a squared, and over here x squared squared gives me x to the 4th. So whenever I see an x squared, I can replace it with a. When I see an x to the 4th, I can replace it with a squared. The reason why I want to do that is because it takes this and changes it into a quadratic. So I see x to the 4th. I can replace x to the 4th with a squared. So I have a squared right here. Then I'm going to subtract 12, and I have x squared, which I know equals a. So I'm going to put an a right there, minus 64. What we're going to do now is we're just going to go ahead and factor this like it was a standard quadratic. So I break it down into two pieces. I consider my factors of 1, which are just 1 and 1. So I have a and a. Then I want to consider my factors of 64. So I have 1 and 64, 2 and 32, 4 and something. And I have 8 and 8. Alright, now what we want to do is get a 12 in the middle. So which one of these, when we add and subtract, will get you 12? Well, it's going to be 4 and 16. Because this is negative, and so is this one. That means one of our answers has to be positive, the other has to be negative. So let's see if that gets us what we want. So we're going to go ahead and FOIL back out just to check. A times a gives me a squared. This gives me a negative 16a. This gives me a positive 4a. And that gives me a negative 64. This in the middle is going to give me the negative 12a that I want. So I went ahead and factored correctly. And this equals 0 still. So now what we've done is we've broken it down into linear terms so far. But what we want to do is we want to go ahead and replace a with x squared. So every time we see an a, since a equals x squared, we're going to replace it back. Now we're not quite done. We want this to be in linear factors if possible. This one we cannot do anything with. This is the addition or sum of squares. We have no way to factor sum of squares. However, we can factor the difference of squares. So we're going to leave x squared plus 4 alone. Then we're going to factor our difference of squares. When you factor the difference of squares, you recognize that your square root of 1 is just 1. And then the square root of 16 is 4. So 4 is going to go here and here. Because this is negative, and it's a difference of squares, one of these is positive, the other is negative. So what I've done is taken this and factored it down as closely as I can into linear factors. This one just does not factor into a linear factor, so we have to leave it as is. We're going to try one more. For this one, what we want to do is we want to go ahead and try and factor. So first we have to pull out anything in common. I notice that there's an x in every term, so I'm going to pull out an x. I get left with x to the fourth minus 5x squared plus 4 equaling 0. Now just like the last problem, hopefully you recognize that this can be turned into a quadratic because it goes down 4, 2, and then 0. We can find a and set a equal to x squared. Then we can square both sides so that when we have a squared, it equals x to the fourth. So wherever you see an x squared, you replace it with a. So we now have x, then a squared. Because I have x to the fourth, I'm going to replace that with a squared. Minus 5a plus 4 equaling 0. Now what I want to do is go ahead and factor this quadratic like normal, except that I'm going to have an a. So my factors of 1 are just 1 and 1. My factors of 4 are 1 and 4 and 2 and 2. Since I want 5 in the middle, I know I'm going to use 1 and 4. Because this is positive, I'm going to make both of these negative. And I am going to get the negative 5 I want in the middle. So I went ahead and factored correctly. Now I want to replace a with x's. So wherever I see an a, I'm going to replace it with an x squared. Now we notice we have difference of squares here and difference of squares here. Because we have that, we can go ahead and factor even more. So I'm just going to do the first two. I'm going to have an x and an x. Because this is a negative 1, I'm going to have plus 1 and minus 1. Over here we're going to do the same thing. Again, we have difference of squares. So the square root of the 1 is just a 1x and a 1x. Then the square root of 4 is 2. So we're going to have 2 here and 2 here. And because it's a minus, we have 1 negative and 1 positive. So I went ahead and taken this and factored it down into my linear terms.